And we are back. What is up, everyone? And welcome back to the HackSmarter Twitch channel or my YouTube channel if you're watching this after the fact. My name is Tyler, and we are going to learn some more AWS pen testing. For those of you on Twitch, we just got done with the 5-minute break. If you're on YouTube, this may be a new video. Either way, thank you for taking the time to hang out with me and learn with me. Without any further ado, let's just dive right back into it. So let's pick up where we left off at. We just finished IAM permissions, and we are going to dive into resource policies and SCPs. I think someone in the chat said, hey, they skipped SCPs. Well, here we go. We got them right here, just in the next room. While 80% of the time when working with AWS, you'll be using IAM policies, there are two other types of policies you need to know about. They use the same statement structure as the IAM policy, but are attached to resources or accounts to affect how access is authorized. All right, let's get started. Accessing the environment, we already did that. We should be good on that part. Resource policies. IAM policies are attached to a specific principal and define the resources the principal can act on, whereas resource policies are attached to a resource and define the principles that can act on the resource. Many resource types can have resource policies, and resource policies are how things become public in AWS. For example, you can attach resource-based policies to S3 buckets, KMS keys, SQS queues, SNS topics, AWS Lambda, secrets, manager secrets, IAM roles. Yes. An assumed role trust policy is a resource policy since it defines the principal who can act. Adjust my mic a little bit. The command to apply a resource policy varies based on the service. S3 buckets are one of the most common use cases for resource policies. For demonstration purposes, we've created a public S3 bucket in another TryHackMe account. This bucket is creatively named TryHackMe public bucket. I wonder if I can actually access this. Would it be S3 TryHackMe public? It is there. Okay. And so there's the bucket policy, of course. So what does it look like? We have the SID, kind of like the description, and make object readable. The effect is allow on everything and allow any user to get objects from the S3 bucket. So you can't write to it. You can just get objects from it. And we are applying that as a wildcard to everything in the TryHackMe public bucket. Make bucket attribute world readable. We have the effect allow, and then we have the principal AWS, which means for everyone in AWS, they can read it, and they can get, which I think means like describe or download or look at them, and also list the bucket, and then we're applying that to the resource, the TryHackMe public bucket. In the case of S3, there are two AWS resources involved, the bucket and the objects in the bucket. The first statement allows anyone, the principal right there, to get object on all the objects in the bucket. The second statement applies only to the bucket itself. Oh yeah, because here's the resources supplying to. Okay. And allows anyone to get the attributes of the bucket and to list the objects in the bucket. Give it a try. Run this command from your attack box in a Cloud Shell session. We just did that. Now try and list the files in the bucket, which we just did that as well. I just use a little bit different syntax here. Resource policies also apply to whom can invoke a Lambda function. We'll cover Lambda in a future module, but try executing this Lambda and then look at the output file. All right. So we are AWS Lambda invoke, and then we have to specify the function name. And you can see this is the ARN here. And then the function is, well, just the time. And then we're going to cat the time, and then we're going to use the JQ Python library. So let's just copy this. Yeah, profile. I thought I specified a region. Am I missing something? Oh, hold up. I know what I'm missing. This needs to go over to here. There we go. I just forgot that we were actually grepping this all out and, well, piping it truly. So here's our result. JQ is not found. What? Let's fix that real quick. There we go. Just giving us the time. Now try looking at the policy for that function. All right. I'm not going to type this all out, but let's look at it. We're doing AWS Lambda get policy, and then we're passing it the function name, and we're querying the policy, and we're putting the output text, and we're passing to the JQ library. So we'll copy this. We'll just need to pen this. Okay. Here we have the SID, IAM module shared resource, public Lambda get policy permission. The effect is allow on the principal, so anyone. And anyone can do what? Well, anyone can get the policy and this specific resource, TryHackMe time. And then we have this one as well, public Lambda invoke permission, allow, so anyone, any principal, wildcard, anyone can do this. Or what can they do? They can invoke the Lambda function. Which Lambda function can they invoke? Well, here's the resource of the one that they can invoke, and that's what we just did. So you guys would actually be able to do this yourselves, I believe. As you can see, the resource policy for this function allows anyone to run Lambda get policy, and all members of the AWS organization, this one, to run Lambda invoke function. Got it. Try running the S3 API command get bucket ownership controls against the TryHackMe public bucket. What is the object ownership value set to? Okay. So AWS S3 API get bucket ownership controls and S3 maybe I need to specify bucket here, not S3. So it'd be bucket. There we go. What is the object ownership value set to? Bucket owner preferred is what it's set to, without the commas, I'd assume. What was the hint? Oh, just telling us the command. We figured that out ourselves. Try invoking the Lambda function TryHackMe quote in the same account. What's the quote returned from the function? We can just go to our previous one. TryHackMe quote. Change this to like quote. Most heard comment at reInvent, dude, Lambda is the coolest ever. Werner Vogel's 2014. All right. So this is the quote. Is it the whole thing? Is it the whole thing that they want? There we go. Service control policies. Service control policies are a function of AWS organizations. They exist outside of the AWS account and are applied by the parent organization's management account. They apply to all principals in the account, including the root user. This is the SCPs someone in the Twitch chat was talking about. Service control policies are leveraged by enterprise security or compliance teams to ensure that the corporate directives for cloud usage bind to even account administrators across an AWS org. They can be, so Dumbledore applies to Dumbledore. They can be configured to prevent disabling CloudTrail, the AWS auditing service, or prevent using AWS services the legal department has not vetted. They can also limit actions to specific roles so that only the global network admin role is permitted to manage VPC route tables. Users in an AWS account cannot view the service control policies applied to the account. Until recently, AWS didn't even tell a user that was denied an action if an SCP was the reason. However, some AWS error messages will now indicate if an SCP denied an action. What are the last 4 words of the error message you get when attempting to disable guard duty with this command? I don't know. Oh, freaking A. Let's go over here. Oh, wait, no, I think I need this actually. I just need to set up my profile, so this is my main profile, so I don't have to keep doing this. AWS guard duty, delete detector, detector ID, profile. Is posting links here allowed? Yeah, but I think this stupid Nightbot thing is configured incorrectly, so he might warn you. But from my perspective, yes, it's allowed. Whoops. I'm going to do it from here. Okay. Okay, cool. It allowed you to share it, and we'll check out that article. Thanks for sharing. I'll pull it up in just a second. Actually, I'll pull it up at the end of this, since we're just about done with this module. Maybe that's the error? What are the last 4 words of the error message you get when attempting to disable guard duty with this command? You guys see something I'm doing wrong? Am I just supposed to do this? Quotes are misplaced? Like in their example right here that they want us to paste, you're saying these quotes are misplaced? I don't quite even understand what this is doing. AWS guard duty. Okay, let's go like this. Okay, let's see if this works. Let's first check it in our terminal. What the heck? There's something weird with the detector ID obtained from list detectors. We can't even list detectors, though. Let's try that. Let's see if we can even list detectors. Maybe that's where it's failing. I can't list detectors. So here's where it must be failing. It wants us to attempt to turn guard duty off, and then we're passing it a detector ID, and the detector ID we're passing it is the output of this message right here. This AWS guard duty list detectors query detector IDs output.txt. And it's not a profile issue. because I'm doing it from the AWS Cloud Shell. Something seems to, I know I said this before with the one question, but something I do think is actually wrong with this question. Because all it's asking us to do is try to disable guard duty. Let's see if we can figure it out. If we go to guard duty here, it's not enabled. We can't disable something that's not enabled. Okay, legit think that's a bug. I wonder if we need to reconfigure our environment though. Let's try this. If we reset our environment, I wonder if that will possibly fix it. While we're resetting our environment, let's check out some of these links you guys are sharing. So from Mesmiro, he said, hey, check out this article. Let's look at it. Unit 42 Cloud Threat Report. Whoops. Misconfigured IAM rules leads to thousands of compromised cloud workloads. We'll read through the executive summary. In the spring of 2020, they were approached by a customer who wanted the group to test the defenses of their AWS infrastructure. The customer ran thousands of workloads, hundreds of S3 buckets, and maintained cloud-native databases with over 500 active development users and nearly 1,000 roles. For this red team exercise, Unit 42 researchers provided limited information about the internal architecture and were given limited access to the environment itself. They were able to gain privileged access to 2 AWS accounts using 2 different IAM misconfigurations. The misconfigurations allowed the researchers to gain access to the cloud as anonymous users and then pivot to source code repositories hosted outside the cloud. Hacks, yo. The first identified misconfiguration exploited a risky combination of policies that allow users with an IAM role to elevate to administrator access, privilege escalation. When hundreds of users are given this role, this opens up many potential apps for exploiting this vulnerability to gain administrative access and compromise the entire cloud. The second exploits an overly permissive IAM trust policy that allows unauthenticated users to gain access to internal resources anonymously. The researchers successfully moved laterally inside the cloud to eventually obtain private keys for search, database creds, and repository source code. After they analyzed severity, they then conducted reconnaissance research on GitHub to look for AWS accounts with misconfigured ones. The research found misconfigured accounts belonging to billion-dollar orgs, a U.S. pharmaceutical company, and a financial company based in Brazil. All these can lead to major data breaches that leak thousands of sensitive details on cloud workloads, such as VM snapshots, database tables, and S3 buckets. Yo, that is crazy. All right, let's check out the one by Diabolico Dope. Welcome to the first Breaches Cloud monthly update. So far in June, we learned the following. Oh, so this is just showing all the different breaches. And if we look over at our access or our tags here, we were talking about IAM users. So if we click that, here's one in a former engineer leveraged AWS creds left over from his time of employment, right? Delete those creds, which result in the deletion of 456 virtual machines. Ooh, crazy. If we just click AWS, and we got a bunch of those. Really cool. Kind of like HackerOne, but for AWS stuff as we look through real life breaches. Thank you guys for sharing. I'm going to check those things out offline. Our environment is still resetting. I don't even know if I needed to set it up, but it's possible, right? Because it has access to the environment here. It may be that we need a separate environment to be generated for this specific room. And I'm guessing why that's why it's taking some time. Refresh the page. Still resetting. All right, well, now you know about IAM principles, how a policy is formed, how SCPs and resource policies interact. Let's dive into how authentication works in AWS's next room, IAM credentials. We'll just complete that. I'm going to keep reading about your guys' breach stuff while we wait. We'll give it a little bit more time. Let's take a little bit for it to build the environment. Let's go back to this link because it seemed quite interesting. I want to just glance through this real quick while our stuff loads. So this is explaining like what IAM does, kind of the things we've been reading about on this TryHackMe learning path so far. And here's where I think it's really important. Now, I'm not an AWS pen tester, guys. I do web app pen testing. AWS is still really new to me, so a lot of this stuff is new to me. But just being able to read policies properly and understanding like what the policy is doing and thinking how you could elevate your privileges, I think that's a huge part of learning AWS pen testing or AWS auditing, whatever term you want to use for it. So here is the principal's permission policies. Let's see if we can read this so far. What is the effect? Well, it allows, and our action is we can pass a role, and it applies to any role in the DevOps EC2 and DevOps ECS. And now we even have conditions here. So our string equals IAM pass to service. So that must apply to everything, right? So we have an explanation here. The principal's permission policy is IAM pass role permission. We got that. The role's name matches the pattern defined in the permission policy's resource field. The target service is listed in the permission policy's condition field, so all of the EC2s. If there is no condition field, the principal can pass a role to any service. The role's trust policy right here allows the target to assume the role. So the trust policy, there's the role name to assume the role of the EC2. If the role is more privileged than the principal can access a service that the role is attached to, then there's potential privilege escalation. Figure 2 illustrates how Unit 42 researchers discovered, exploited, and eventually gained administrative access in the customer's AWS cloud environment. Researchers identified and confirmed the step-by-step actions an attacker could take to compromise an environment. Let's check our environment. Jeez, it's still resetting. Diabolical said, can I get alpha access to this path for testing? I have no idea, dude. I don't work for TryHackMe, so I don't have an in on how this path works or what permissions are given. And let's check out that breach stuff as well. Let's look at a few more of those breaches while we wait. If it's not ready in just a little bit, I might just move forward and I'll come back and answer that last question at some point in time. I wonder if we could even just let's ask this. What? I don't know if ChatGPT can actually help us with this. Oh man. Okay, let's see if this is actually right. Oh, you finished, no need to restart, completed in Cloud Shell? What am I doing wrong then? I'm typing the exact command into Cloud Shell. Right? I'm really curious now, Cali Max. I know we have like a 5-second delay, but did you just type this exact command? It doesn't work for me. Oh, look, my environment's not ready to use. You just copy and pasted that command. Like, look. You see anything I'm doing wrong here? Something's funky about mine. I'm literally copy and pasting the command. Cali Max, what's the answer then, dude? Just so it doesn't drive me crazy. Please tell me. It's not denial by an SCP. Okay, with an explicit deny. That's crazy. It doesn't work for me. Especially if we type the same exact command. But oh well, we got the answer. And basically what it's teaching us is that if the SCP is set, you can't delete it. And guard duty should be set up. I'd be curious, Cali Max, in the console version, if you go to guard duty, does it show it as enabled? Because here, I think, is the problem. Guard duty is not even enabled on this account. Like, look, it wants me to get started. So we can't try to disable something that's not there. Guard duty is not enabled on this account. Therefore, we can't attempt to disable it. Seems to be the issue. But, oh well, It is done. We've completed this room. Guys, I know that was a little bit of a shorter room, but we'll probably do one more room. Let's take a 5-minute break and we'll dive into another room in a second. So those watching on YouTube, this is the end of this video. Jump to the next one. For those on Twitch, get up, jump around, do jumping jacks, and we'll be back in 5 minutes.